While we are aware of buoyancy being used to convert wave power into electricity, we seem to neglect the idea of using the very powerful buoyancy forces as a direct tool at locations away from the sea. This is definitely a mistake, because serious levels of power can be generated from such a system. However, this style of energy generation is more suited to business or factory levels of power, where power generation costing 1 American cent per kilowatt hour can be produced, provided that you have some $3.75 million US available for the construction costs. One such system is the hydro self-powered generator of James Kwok. There's no magic trick with the hydro, which is a design from James Kwok, CPeng FIE Ost MECE, Chartered Professional Engineer and Fellow of the Institution of Engineers of Australia. A low-pressure air chamber will sink in water due to gravity if the chamber is heavier than the air chamber will sustain with its buoyancy. If the air pressure in the chamber is increased, then it will rise in the water due to buoyancy. There are 3 ways by which the mechanism harvests energy in the process. 1. The moving chambers are arranged as a linear electric generator, so that the movement of their magnets along coils in the shaft generates electricity. 2. The connecting cables impart their movement via rack and pinion gearing into a flywheel to run an electric generator. And 3. Pneumatic hydraulic cylinders are pressurized for storage to be released into a turbo generator. The claim is that despite the losses from friction of the cylinders moving through water and the other moving parts, that more energy is generated to keep the pressurization stroke depressurization cycle going, and there is a net energy gain. The company says that the footprint area of a 1 megawatt hydro plus plant is approximately 600 square meters by 19 meters high. That's about 2,000 square feet at 62 feet high. There is a description in Chinese at www.hydroonline.com. The generator sizes suggested by the company are 250 kilowatts, 500 kilowatts, and 1,000 kilowatts, which is a megawatt. Part of the patent application which James made is shown here. It is US 2010 0307 149A1, dated the 9th of December 2010. The inventor, of course, being James Kwok. It's entitled Hydrodynamic Energy Generation System. The patent has a number of very explicit drawings, and they're shown here with information as to how the thing operates, and with the specific numbers showing each particular part of the design. Just in broad outline, flotation cylinder moves up in the water inside this container, and it turns the top of the rod that is mounted on due to the spiral groove that it travels along. It's stopped from rotating itself by having 2 sliders on a vertical fixed rod alongside it. That creates a turning motion here, which spins the shaft of a generator mounted above here, which is a neat arrangement. The air going into and out of the particular buoyancy chamber is collected in or supplied by containers inside the actual structure itself. I don't want to go into the full detail of every item and particular detail of this style of operation. It is shown here in detail, and you're welcome to work through it step by step until you understand fully exactly how it operates. The detail is considerable and the information is very interesting. There are of course two of these flotation devices located inside the water contained inside this general structure. A word of warning, and that is that the weight of water involved in a generator of this size is very substantial. Water weighs 62 pounds per cubic meter of cubic foot of fresh water and 64 pounds per cubic foot of seawater. So with the large structure involved, you have a very high weight of water inside the structure itself. This diagram here shows the arrangement, and with storage tanks and pressurized air tanks underneath and the feeding pipes and everything, you have a large volume of water physically sitting on this structure here. It's got the generating apparatus for electricity at the bottom, as well as additional generating capacity at the top. And you notice that there are several steps leading up to the part that is supporting the actual container of water. And the container of water is very substantial, as you see from the introductory information. You're looking at more than 60-foot depth of water, and that is a lot in the way of physical weight of the material itself. You also need to pay attention to the fact that you need pipes to carry the gas, and this table here shows you the difference of the volume of gas that can be pumped in any particular period of time. They've chosen one period of time, and they're showing both the length of the pipe in feet and the pipe size inside diameter and the nominal pipe description that you use when you're ordering it. But you notice that a half inch, 0.622 inch inner diameter for just a 10-foot length of pipe will only pump 120 cubic units through the pipe, whereas an 8-inch nominal pipe will pump in that same period of time 7.98 of the same units, or with a 300-foot length it will do 25,895 units. You notice the major difference in carrying capacity of any of these pipes with just a change from a 10-foot, which is 3-meter length, to a modest 20-foot, 6-meter length. And those lengths are the sort of lengths needed for many applications. Also look at the figures for the half-inch nominal diameter pipe. With just a 10-foot length, it would take a full 2 minutes to pump just 1 cubic foot of air through it. It follows then that pipes of considerably larger diameter are genuinely needed for a project like the hydro. It's possible to construct a much more simple buoyancy generator, and if necessary, one which is a good deal smaller, perhaps like this. You have a container of water as before, and you've got a series of buckets attached to a cable which runs round two pulley wheels which have got a metal shaft to support the pulley wheels. The buckets on one side are all full of water. On the other side, thanks to an air pump operating just under the support for the tank, pumps air up into the buckets as they come down and around and are moving up. So in all the period when this bucket is moving up, before this bucket comes round to get in the way, you get air from your air pump filling the container. Now those buckets with air inside them are very much lighter than the buckets with water inside them, and that gives a strong rotational energy to the power output shaft, which in this instant has been chosen at the bottom of the structure. You don't have to do it that way, of course. You can have one or more rotating shafts submerged in water in such a way that they're effectively positioned one above the other. Each shaft has one, and preferably two or more, sprocket wheels mounted on it. Each of these sprocket wheels engages with a continuous chain loop, which also engages with the sprocket of the wheel which is positioned vertically above it. These vertical chain loops form a belt-style support for a series of identical buckets. On one side of the vertical belt, the buckets have their open face upwards, and on the other side, the bucket openings are facing downwards. An air pump is positioned directly underneath the set of buckets, which have the bucket openings facing downwards. The air pump generates an upward moving stream of air which collects in the rising buckets, displacing the water filling the bucket. This results in a powerful upward thrust caused by the buoyancy of that bucket, and the thrust causes the bucket to move upwards, rotating both the horizontal shafts and bringing another water-filled bucket into position above the air pump. A gearing system transfers the rotational torque thus produced to a generator which produces electricity for general purposes. This is a generator whose input shaft is rotated through buoyancy caused by air-filled containers submerged in a tank of water or some other suitable heavy liquid. Continuous powerful rotation of the generator shaft is produced through the use of one or more conventional, commercially available air pumps. The air pump is used to fill a series of containers which are open at one end and which are attached to what is effectively a belt arrangement created by two strong chain link loops which mesh with sprocket wheels mounted on the two shafts, either or both of which can be used for the extraction of useful power, preferably for driving an electricity generator, but not necessarily limited to that function, as any powerful torque has many useful applications. Objectives are to provide a power generation system which is very simple in form and which can be understood, operated and maintained by people with minimal training. Also, a system which uses components which are readily available, thus avoiding significant manufacturing costs, and one which operates without the need for any kind of complex mechanism or high precision equipment, and which can operate with a wide range of commercially available products. As the chain continues round the sprocket wheels, the bucket, which is being forced upwards through the water by the pressure of air inside it versus the water inside the opposing one, spills the air as it reaches the top above the pulley wheel. The air runs straight out as the bucket turns round, and then as the bucket goes down it's filled continuously and fully with water. This is basically a very simple system and one that's quite easy to set up. The side view for something like this in the most commonly used type of operation is where the bucket, which is most of the width of the actual tank, turns the upper power shaft, which has got a drive wheel on it which connects with the generator. The drive wheel is a good deal bigger on the water immersed shaft compared to the drive wheel on the alternator or generator itself. That gives you a gearing up so that the alternator shaft is spun much more rapidly than the shaft turning inside the water. You can have, of course, more than one of these units attached side by side, and the same shaft can be used to drive the alternator, possibly through a bigger gearing up ratio, so that you get a very fast rotation of the alternator shaft, generating the necessary power for you. There is an alternative method to be used, which is you can pump the air from above the water surface. That doesn't sound like anything very great when you are just told about it, but it is quite important. The arrangement is that where you have the situation where there are wells that have dried out and are not going to work anymore, you can then coat the sides of the well with concrete, and then you can use your apparatus from above ground to both draw off the power and to feed the air into the buckets from above. That is a very cheap and convenient way of doing it. It's not a bad idea to have a cowl which concentrates the flow of water and air as an upward stream going into the buckets. It has been suggested that wells which have gone dry in India might be faced with concrete and the air fed from the surface in order to generate electricity where it's just not available. This simple arrangement has the added advantage that the electrical generator is located above the water surface, and so it's easy to get at it for both installation and servicing.